Hello, my name is Randy Chong, and I'll be presenting three content of our business proposal. The first one is the project overview, the second one is the project approach, and then the third one is the project outcome. So now let's jump or understanding the scope of our project. The scope of our project is to develop a project to address the water shortage issue faced by student Universiti Malaysia Sabah within 12 months utilizing the 3 million allocated by Prime Minister Dr. Sri Anwar Ibrahim. Understanding the project scope, therefore we produce five objectives for this business proposal. The first one is immediate relief, sustainable management, spread conservation awareness, enhancing readily available infrastructure, and implement advanced technology. Now allow me to briefly explain five of these objectives. The first one, immediate relief. The immediate relief will provide a temporary water supply solution to alleviate the acute shortage faced by the students in residence of UMS. And then the sustainable management. So we try to explore the sustainable water sources like groundwater extraction through hydrological studies. And then the third one, spread conservation awareness, is we try to educate the campus community on water conservation practices. The fourth one, enhancing the readily available infrastructure, is to assess and upgrade the existing outdated water pipeline, storage tanks, and pumping system to eliminate the bottleneck and efficiencies. And the last one is to implement advanced technology. We try to deploy an IoT-based monitoring and control system, for example, like smart water, leak detection, and so on. So we're entering the very important part of the content in business proposal, that is the project approach. So the project approach for our business proposal is first, assessment of existing water infrastructure, exploring sustainable management, decentralized treatment system, and the fourth one, IoT-based monitoring controls and control. So assessment of existing water infrastructure in this step include the evaluation of the condition and capacity of current water supply, systems such as pipelines, so on. In exploring sustainable management, this involves conducting hydrogeological studies to assess the feasibility of drilling deep bore wells for tapping underground water. Decentralized treatment system is a system where we separate our current centralized treatment system in Telibung. We try to make one modular water treatment plant in UMS. And the fourth one is IoT-based monitoring control system. In this project, we'll deploy an IoT-based monitoring control system, such as leak detection system and smart water meter quality, and so on.
Next, I'm going to talk about the resource required in this project. So in this project, the resources required mainly divided into three parts, which is the designing steps, IoT implementation, and construction and maintenance. So in designing steps, the resources required mainly aligns to the professional human resource, which, for example, like civil engineers, electronics engineers, environmental engineers, geologists, hydrogeologists for our infrastructure assessment and design. And we also need technicians for installation and maintenance of the hardware, and data analysts for monitoring and analyzing the water usage data. And of course, we need a project manager in these steps for planning and coordination, and to determine the feasibility and the quality of groundwater extraction. So we will need to locate the place in the campus for underground water resource also. And for the next step, IoT implementation, they are mainly divided into software and hardware. So in software part, the data analytics platform is needed for real-time monitoring and analysis. And for the hardware part, IoT sensors such as flow meters, pressure sensors, water quality sensors are needed, and control devices such as valve, pumps, and actuators are needed. And communication modules such as IoT gateways and routers and networking equipment also needed in this stage. And of course, last but not least, servers and cloud infrastructure is important for the data storage and processing this step. And lastly, for the construction and maintenance step, the resources required such as vendors, contractors are needed to supply and install new equipment and treatment system and do the further maintenance for them. Besides that, the infrastructure needed in these steps will be like pipelines and fittings for water distribution, the storage tank for water reserves, the power supply for IoT device and control systems, and also the internet connectivity for data transmission and remote access while doing maintenance and constant monitoring. So there are basically 6 milestones in our project. So the first milestone will be the infrastructure assessment and hydrogeological studies. So the initiate assessment of existing water infrastructure will be conducted, such as evaluate the condition and capacity of water supply pipelines, storage tank and pumps, and identify the bottlenecks, leakage and inefficiencies using flow meter and pressure sensors. And the hydrogeological studies will be initiated to assess feasibility of deep bore wells, such as determine the quality of underground water extraction and locate the potential underground water source. And the data collected from both the infrastructure assessment and hydrogeological studies will be analyzed in this milestone also. So in milestone 2, it is the design of the water management system. In this milestone, it is planned to develop a plan for improving the existing water distribution system and prepare the design for the campus-wide rainwater harvesting system. And the planning and design of decentralized water treatment system will be initiated also. The strategic locations for modular water treatment plants will be identified and the required treatment capacity and technology will be determined. And of course, all the designs of rainwater housing systems and decentralized water treatment system will be finalized in this stage, in this milestone 2. The milestone 3 will be the installation and construction of the system. So the installation of the rainwater harvesting system will be started and the procurement and installation of smart leak detection system will be also initiated. In the smart leak detection systems, the installation of smart water meters, quality sensors and pressure loggers will be required, and the construction for the decentralized water treatment plants will also started, and the implementation of the smart automation and control system will be also be done in milestone 3. And last but not least, the progress of the deep bore well drilling will be evaluated. In milestone 4 will be the integration of decentralized water treatment system with the existing water supply in campus. So in this milestone, it will basically focus on the integration of the newly built system with the existing water supply in the campus. After milestone 4, milestone 5 will be testing and optimization. So in this milestone, the system which integrated with the existing water supply will be tested and optimized, and testing will be conducted and commissioning of the entire water infrastructure. And the performance of the implemented solutions will be evaluated also, and adjustment and optimization will be done if necessary. And after all the testing and optimizations are done in milestone 5, the milestone 6 will be the final project report. And this is basically involved by the developer and contractors which involved in the constructions. So in this milestone basically involved of the paperwork by the contractor and developer, and they will finalize the whole project report and hand over the report to the university management for publication. So these are the 6 milestones involved in our project, which is estimated to be done within a year.
Hello everyone. So now I will proceed to the budget for the smart water management system. So in this smart water management system project, so our budget for this at Universiti Malaysia Sabah is estimated to be 3.0 million as per the allocation announced by the Prime Minister. So now I will proceed to the expenditure budget amount for the first part, that is infrastructure assessment and the design. So in this aspect, we have 3 of the civil engineer, 2 of the electronic engineer, 2 of the environmental engineer, and 1 of the geologist, 2 of the hydrogeologists, 5 of the technician, and 2 of the data analysis, and 2 of the project managers. So in this aspect, we can found that we have 5 of the technician that is the most important and in the this infrastructure assessment and the design. So this of the engineers will cost us 1.656 million for ringgit in Malaysia. Now I will proceed to the second part, that is IoT implementation. So we have included the data analysis platform, IoT sensor control device communication modules, network requirement, and the server cloud infrastructure. So this of the IoT implementation will cost us 310k for ringgit Malaysia. And the last is the equipment and the treatment system that have involved vendor, contractor, pipeline, storage tanks, and the power supply and internet connectivity. So this of the equipment and the treatment system will cost 730k for ringgit Malaysia. So in the total cost of the these three parts, so will cost us 2.696 million for ringgit Malaysia. So after that, we need to minus, so we need to estimate budget amount minus the total cost of the expenditure budget amount. So it's 3.0 million minus the 2.696 million ringgit Malaysia. So our remainder will be 304k ringgit Malaysia. So that's all for our budget in the smart water management system.
So upon successfully done this project or finish this project, the expected project outcome will be the water supply will be increased. And then the second one is to reduce the water losses due to the implementation of water metering, detection, or the IoT just now we are discussing. And the third one, the water quality will be improved due to decentralized of water treatment plants. And then the fourth one, real-time monitoring, that is the implementation of IoT-based monitoring system. And then the last one, the most important one is the long-term sustainability. So not only this project will establish a very good project outcome, it also will follow the UN proposed SDG. That's it.
So hello everyone. So now I will proceed to the potential risk and the mitigation strategy. So we have four of the potential risks. The first is the technical risk. So the technical risk will be the challenge in the integrating new decentralized and the treatment system with the existing supply. Second of the technical risk is the malfunctioning or if effective IoT-based monitoring and control system. So we have the mitigation strategy to solve this technical risk. So we can involve stakeholder in the design process and ensure the seamless integration through planning and testing. Besides that, we can also ensure regular maintenance. So engage the IoT expert to design a robust and reliable system with redundancy and backup. So the second part is the operational risk. So operation risk can be defined as the insufficient or inadequately trained personnel to operate and maintain the new system. So besides that, we have also disruption to water supply during the implementation. So the mitigation strategy to solve these two operation risks is to develop a comprehensive training program for relevant staff and allocate resource for ongoing support. Besides that, we can also develop a detailed plan to minimize disruption and coordinate closely with the campus community to solve these operational risks. Thanks. So now I will proceed the third part of the potential risk, that is the financial risk. So the financial risk will be the cost overrun due to unforeseen expenses of scope change. Besides that, it also have a delay in securing the necessary funds or budget constraints. So in this mitigation strategy, so we can conduct through cost estimation, include contingency funds, and establish robust project management practice. Besides that, we can engage with authorities to ensure timely release of the allocated budget and explore alternating funding source if needed. Last is the regulatory and environmental risk. So we have the compliance issue with environmental regulation or water quality standard. So besides that, we have the potential environmental impact from groundwater extraction or wastewater discharge. So in my mitigation strategy to solve this risk, so we can ensure the project design and implementation adhere to all relevant regulation and collaborate with regulatory authorities. Besides that, we can also conduct comprehensive environmental impact assessment and implement appropriate mitigation measures. That's all for our group. Thanks.